All right, so I'd like to extend a really warm welcome to everyone for joining into the demo day for Data Engineer Camp. So the agenda for today is I'm going to run through a quick introduction to the bootcamp, what we cover and what the students have done over the course of the 16 weeks. Then we're going to dive right into the reason why you all are here, which is to look at the project presentations. And then towards the end, we're going to have a quick round of networking as well for you to interact with the students and for the students to get to know you and to have some industry discussions as well about what you're thinking is going to happen in the future for data engineering. All right, so let's first off, just a massive congratulations again to the bootcamp participants. Awesome work and congratulations on completing the 16 weeks course. I'm aware some of you have to kind of wake up really early in the mornings and some of you have to stay late into the evenings to complete the course. And so you stuck it through and you've made it through to the end. So kudos to you for getting the bootcamp completed. Little bit about background on the professionals and students that are enrolled in our course. So this cohort, we have students from all around the world. I think there's something like 9 countries that the students are from. I didn't kind of map every student out here, but students are from around the world, like places like Australia, Singapore, India, the US, different parts of Europe, and even places like Chile as well. The students as well are professionals who are working in the industry. So most students have a full-time job and they currently work in the data or software industry in various roles like a data analyst, a software engineer, etc. Some examples of companies that they currently work at are places like Atlassian, Apple, MyFitnessPal, etc. Okay, so who have been teaching these students? So the students have been trained from experienced instructors such as myself. I'm Jonathan Neo, I'm an instructor here at the bootcamp, and I currently work as a data engineer at Canva. We also have Hengji Liu, who is an instructor with the bootcamp and a data engineer at Canva. Pavan Raju, an instructor with the bootcamp, a data engineer at Deloitte, and Douglas Robertson, who is our career services officer and the director and founder of DR Recruitment Services. So yeah, that is to say that instructors for the bootcamp are experienced and practicing professionals and data engineers. So quick run through over the curriculum, and then we'll jump into presentations. So the students have completed the 16 weeks of content. And what the content entails is the first 4 weeks we're going to cover, we've covered off the data engineering fundamentals like Python, SQL, Amazon, Docker, followed by a project. Then we dive into data engineering frameworks and tools, such as data integration using Airbyte, followed by data warehousing with Snowflake and dbt, data modeling techniques, such as Kimball dimensional modeling, one big table, and also semantic layer modeling with Preset, data lake housing with Databricks, Spark, Great Expectations, and Delta Lake, data orchestration with Airflow, real-time stream processing with Kafka and ClickHouse, CI/CD and infrastructure as code with GitHub Actions and Terraform. So yeah, we cover a wide range of topics from the introductory side all the way through to the advanced topics. Quick word on the next cohort. The next cohort is kicking off on the 31st of July. We have capped the seats for this cohort to 30 seats. We've currently filled 18 and there's 12 to go. So if you do want to enroll or you have friends that are interested in the bootcamp, feel free to let them know and just send them the link to our website and we can start enrollments with them. All right, that brings us now to the project presentations. I'm really excited to kick us off. The first presentation we'll have is from Ajay. The second presentation is from Puja, and the third is going to be from Dennis. The presentation format is going to be 10 to 12 minutes presentation, followed by a 3 to 5 minutes of Q&A time. And feel free to also provide your feedback to help our presenters improve. So if you have any thoughts, suggestions on what they can do to improve, feel free to unmute yourself or drop it in the chat and suggest to our presenters how they can improve for next time. All right, with that said, we're going to kick off with the first presentation. So I'll hand it over to you, Ajay. Feel free to go ahead and share your screen.
Okay, so let's get started. So this, the project that I created was to stream AWS logs and do some sort of analysis on that. So for streaming, I created, let me first show what's the problem statement, right? So if I go into the slideshow mode, so here's the problem statement. right now, if we try to stream any logs from CloudWatch, which is an AWS logging service, it takes up to 12 hours for those logs to be dumped into an S3 bucket, post which we can do some sort of analysis on that. So that's supported by this AWS documentation as well, where it says that there is a 12-hour lag from when you can export the logs to do some sort of analysis, right? Now, before I go into more details on this particular solution, let me just show you what we are talking about, right? So I have an EC2 instance hosted here on AWS, and I have a web server hosted on that particular EC2 instance. So this is the web page right now that is created on this. Now, every time I go and access this web page, or anyone on the internet accesses this web page, I've configured the logs to be sent to the CloudWatch log group in AWS. CloudWatch is the logging service where the log goes. Now, once the logs are in this CloudWatch log service, I'm using a Kafka cluster to stream those logs. So there is one CloudWatch source connector, and there is one S3 sync connector, right? So from the source connector, we connect to the CloudWatch service to get the logs. And in the S3 sync connector, we dump those logs into an S3 bucket in JSON format. After which, I'm using Databricks to do analysis on those logs. So you'll find all the queries here. After that particular analysis, we have some goal tables, output of which is shown here in the form of a preset dashboard. So you'll see all sort of analytics here. How many requests have been from which country? The top 10 requests from each country. Requests made by time of day, right? So I receive most requests from 6 to 11. Then requests per day. Then we have browser types, from which browser we are getting most requests. That's Google Chrome. If there are any errors, then what kind of error codes are more prominent? So I see 404 is most prominent. A total of 5,000 requests have been made, close to 5,000, and 4.24 data has been served as part of those requests. I've configured this dashboard to update every 5 minutes. That's where you see even today's data there, right? So I see today's run has not been completed. So let me run that. By the time we are back here, it should complete. Okay, so let's go back to the presentation. So the solution, as I explained, we export the CloudWatch logs through a CloudWatch. We export the logs from the EC2 instance using a CloudWatch agent. We send them to CloudWatch, and then we stream them to an S3 bucket using Kafka. And then we do the analysis in Databricks, and we visualize it in Preset. This is the solution architecture. The web server is hosted on the EC2 instance. We have an agent installed. The logs go to CloudWatch. This is the Kafka, which is hosted on Confluent, from where we get the logs into an S3 bucket. Databricks analysis is run, and the visualization dashboard is updated every 5 minutes. Now, to configure all of this, I've done a few setups. So we'll start with the AWS EC2 instance. First, I've created an instance profile. This is required for the EC2 instance to have access to CloudWatch logs, so that it has access to dump all of the logs into CloudWatch, right? So that's this policy. Now I've attached this policy to a role. This is the EC2 role. Now, apart from this, the EC2 instance will also need a security group in which it should have public access, right? Because I want my server, my website that is hosted here, to be accessed by everyone on the web, right? So that's where you see public access on this particular EC2 instance. Now, this is the EC2 instance. It has a public IPv4 address through which we are accessing this particular website. Now on this EC2 instance, we have done a few configurations. The first one is installing the Apache server. This is needed so that the EC2 instance can act as a web server. It can host a website, a web page. So for that, I use this command. Now, after the Apache server is installed, we start that particular service. After the service is started, the access logs and error logs. So let's say I access this particular website, right? The access logs will go to the access log file. And if there is a request which errors out, it goes to error log. These two files will come in handy later on. Now, continuing on with the EC2 instance configuration, I installed the CloudWatch agent. I configured the CloudWatch agent file in which two kinds of configuration are done. In the first file, I've configured the region where my instance is. In the second file, I've mentioned the file name, which I want to stream, right? I want to stream my access logs. Here is the CloudWatch log group in which all of the logs are going. So it's named CloudWatch logs EC2. Now inside this, if you see the format of logs, all of these logs of every kind, HTTP, SSH, any kind of request goes here into CloudWatch. Now after that, I have a Confluent Kafka cluster running in the same region as my instance is hosted. This will come in handy later on. After that, I have the CloudWatch connector. The most important properties are the Kafka key and the AWS access key and the AWS logs URL. Using this, it can access the CloudWatch logs. Then I have S3 sync connector. Here, the most important things are again, the Kafka API key and secret, the AWS access key, and the bucket name. Here you can see the output data format is JSON. That's how the data, even though it's in string format, it gets dumped into .json files. I'll show later on why I use JSON files. And then once we have dumped all of this data into this particular bucket, Airbyte shared bucket 2, we mount that in Databricks, because using that, we'll be reading that particular file. So we have a database configured there. We have a staging table, which is a Hive external table, which reads all the updated data from this particular bucket. We have a Delta table, which stores all of these logs incrementally based on new data that comes into this staging table. Now, web server log entry typically contains all of these parameters, but they are in no specific format. There is no delimiter which separates these. So it is especially tough to convert this into different columns. That's where I used a JSON format and read it as a string. So if I go to the last slides, you'll see I'm reading the whole value as a string. So that was the reason I dumped all of it into a JSON file and read it as a string. And then later on in my transform table, I converted all of them into separate columns: IP address, date time, what was the request method, status code, and everything. Now, apart from this, I also used another web service called MaxMind GeoLite 2 city database. So this basically helps us convert IP addresses into city and countries, right? So they provide an MMDB database, which you can download with a license key. So I signed up for that. That's a free service. And using that service, using this reader method, I was able to extract city and country details for every IP. And then I registered that PySpark code into a UDF. And this UDF was used in SQL to convert all the IP addresses to city and countries. After all of my transformations were done, I created these goal tables, which contain all of the data that you see on this preset dashboard, right? Requests by country, requests per day, total requests. So all of these are those tables. While doing this, all of these transformations were used: sum, date trunk, group by exists, count, between, decode. There is a Databricks workflow which runs automatically every day. It can be scheduled even earlier, every 5 minutes, every 2 minutes, so that it updates more frequently. this helps run the worksheet on a schedule. In Preset, I've created all of those data sets based on the goal tables. Based on those data sets, I've created charts, and based on those charts, I've created this particular dashboard. So that was all. Any questions from anyone?
Suppose, AJ, did you want to show some interesting facts about your dashboard? I think there was a peak traffic moment. You want to talk towards that?
Yeah. So since this is a non-secured Apache installation, I did not configure any security rules. This is a public server. I can only access this using HTTP. You can go ahead and access it using SSH and everything. So on this particular date, this server was hacked. Somebody changed the API key, after which I was unable to access the instance. I had to delete the instance, reconfigure the EC2 instance to the same log bucket, to the same log group. So that's where you see this peak request. On this, there was a suggestion that Pawan made. Pawan is one of the instructors in the course, that this dashboard, these analytics can be used for such events as well. If you see higher than, let's say 900 traffic, 600 traffic, where you haven't seen it before, you can configure notifications to your email, so that if such event occurs, you would know that it requires your attention, something is going wrong or something is going absolutely correct. Your website is running on full load.
Oh, yeah, thanks, AJ. Yeah, opening up to the floor for any questions, comments, feedback, even if you have any thoughts.
No questions from me, but just well done on that one. I think it's a really practical project, and we underestimate where data engineering could be applied, I think, sometimes in collecting application metrics instead of trying to funnel stuff for business dashboards that nobody might look at. It's a really, really cool idea. I really enjoyed this presentation.
Oh, anyone else? Any questions?
Can I ask, what's the most challenging thing that you've experienced in this project?
I would say the most challenging part was these connectors, because let me show you one of the request formats, right? So if you can see this particular request format, it looks like it has a separator / double quotes, but this comes in sometimes in the request method, sometimes in the user agents. So I was unable to figure out how to break down this particular request, this complete request, which is basically a string, into multiple columns, right? So I tried out different formats in Kafka, right? JSON format, bytes, string, but I felt that JSON was the most helpful here, because what I did was, let me show you my Databricks. In Databricks, I created an external Hive table. So every time that table gets dropped and recreated, but that doesn't impact the performance. Why is that? Because this is an external table. It is using text format. That means the JSON file are read as text. And this table will cause any performance impact or anything when it is read, right? Because this schema that we are creating is stored in Hive metastore. So whether I drop this table, whether I recreate it, it completes within seconds. Every time it will take the same amount of time, because it is schema on read. It's not schema on create. So this was the most challenging part, on how to read the files, what format to use. how to get Databricks working with Kafka. Rest of it was quite familiar, as I've earlier worked on AWS. Working on dashboards, I'm familiar with that. So this was the most challenging part.
Thank you. I think I like how it's just, every time it's just the configuration that's always taking the most time. And then yeah, everything else it will just be smooth sailing. Yep. Thank you.
Oh, Nick Tantra, did you have a question? I saw you unmute yourself just now as well.
Yeah, I was wondering, like, since you got hacked, do you find out who actually hacked you or which country hacked you? And specifically, is there anything we or you can do next time to avoid it?
Yes, probably secure your EC2 instance properly. But since I wanted my website to be publicly available, that's how I got this amount of traffic, right? If I go to preset dashboard, if only I would have accessed it, you would have seen India as the highest count. But right now it's public, so everyone is able to access it all over the world. I believe somebody from US was able to hack into this EC2 instance. That's the most amount of requests that went through. Yeah. So next time I would probably secure my EC2 instance before making it public.
Thank you.
Oh, all right. Thanks, AJ. We'll have some more time for you to interact with AJ if you like in a networking session as well. But yeah, thank you, AJ. We'll give the baton over to our next presenter. So our next presenter is Puja. Puja, would you like to go ahead and share your screen?
Thank you, Jonathan.
And feel free to turn your camera as well if that's convenient for you.
Okay. So, hello everyone. So I'm going to give my project detail on weather API analysis, which was presented by me on the capstone project by our group 1. So moving forward, what this project is. So the project context and the goals. So the objective of this project is to make weather changes based on different parameters such as humidity, temperature, and weather description, and pressure and the wind speed. Since we get current and the forecasted weathers, so we are making insightful into the weather different parameters. So make it more useful for the different data analysts and weather specialists to pull the data from the Snowflake and make it visualization betterly. So we are using the different process of extract, load, and transform. So the data set is sourced from weatherstack.com. So this is the REST API, which we have used in our project in order to get the data set. So moving forward, this is the solution architecture for the ELT, extract, load, transform. So for the weather stack API, we have taken from the URL, just we have mentioned in the previous slide, in which for the streaming process, we have used Airbyte as well as Kafka. Kafka is used here because we are targeting more for the live data set, and Airbyte is also for the live data set, but here more is they are giving different tables for the forecasted and the current through the Airbyte, and the Kafka is giving just the live data set. So different type of tables are generated through Airbyte and through Kafka. We will see in the later slides. For the extract and the load, we have used the Snowflake as a data warehousing tool, and we have applied DBT for our transformation and dimensional modeling. And for the continuous integration, we have used GitHub, and the whole process is deployed through Docker on the Airflow that we will see in the later slide. And for the visualization process, we have used Power BI. So moving forward, for the extraction through the Airbyte source, we have extracted the current and the forecasted weather through Airbyte for the city called California. We have used different city for the Kafka extraction and for the Airbyte. So this is how we have connected our source, and this is for the loading to the Snowflake. Airbyte role, Airbyte destination. And for the connection of the Airbyte, we have used full refresh and append, and full refresh append because there is only one option for the free subscription that we have got from the weather stack to the Snowflake. So you can see full refresh and append has been used as an increments. So this is the role for the Snowflake for the Airbyte. So for the Kafka, for the live data set, we have used for the Jakarta city. We have used for this source. This is the source. And for the sync, we have used these connections for making it connecting with the Snowflake from the data set. So this is the demo of the tables that we have generated. Like for the through the Airbyte, we have got these tables like weather code, weather, wind degree, temperature, wind speed, visibility, cloud cover. These are some of the parameters we got from the data set. And we have got current and the forecast data set through the Airbyte because it is not a live streaming data. So we have got the forecasted and the current, and that we will be using in our project in order to show what is the difference between the current and the forecast. For the Kafka, we are getting the live data. So you can see it is in the JSON format, which is quite different from the Airbyte data set. So we need to flatten it in order to make it more better for our transformation process. So you can see like two data we have got, like record metadata and record current, in which we are using only record content in order for our transformation and visualization. So moving forward, so for the DBT process, for the data build tool, we have sourced from, we have stored in the Snowflake through extract and load, in which you can see like Airbyte schema, Airbyte database, and Airbyte schema is the schema name. Tables are there for like California current weather, California weather location, California weather current, and California weather location, which we have got from the Airbyte data, Airbyte connector. And through topic one is extracted from the Kafka connector, which is a live streaming data. So we have make a YML file for this, and this you can see the source. And for the staging part, we have not done transformation. We have just make the YML file and just extracted the columns. Like you can see staging weather current location, weather current forecast, weather current location for forecast, and for the Jakarta, we have just make the alias generation. In the serving part, we have make most of the transformation. Like for the California data set, you have seen in the earlier slide, you might have seen weather code. So the weather code must be transcribed to any weather description in order to make the better insights into this. So we have made such transformations, like we can get the average difference between the forecasted and the current location, and different codes need to be encrypted in order to get the insightful, and the location and the weather is also joined. And for the live streaming data, we have used like average, max, mean for the per day analysis, and weather codes. We have also used different types of joins in order to make better. And for the dimensional modeling part, different columns of the weather current has been used, in which we have used surrogate key through the db.utils package, and the fact table in which different dimensions have been joined through the surrogate key in order to make a better business context idea. For the Kafka, same we have done for the dimensional model and the facts table for the average and the max mean. So moving forward, we have also done DBT seeds in order to get the weather code joined with the weather description. Like you can see the weather code and the conditions has been defined here to the DBT seeds. Snapshots have been generated in order to capture the changes through the unique keys, in which you can see weather current has only been used because there was in other tables, there was lack of primary tree. So for that purpose, we have used this, and date and time columns were not there. So in the macros, we have developed different type of macros like weather code condition, in which if we give the weather code, it will directly take out what condition it is showing. And for the difference between the current and the forecasted. And different types of tests have been done, like singular tests. You can see like minimum temperatures should be greater than 0. And for the inbuilt test, like null and unique has been performed in the different models. So these are the summary of the different transformation applied, like alias, inner join, cross join those table in where there was no similarity in the columns. And again, distinct has been performed. So there is no repetition of the column, where maximum, minimum, average, and difference. So these are some of the results, like you can see for the California data set, average forecasted, average humidity, average temperature. And here you can see for the seats table has been joined with the weather codes, in which 116 is showing partly cloudy. This is the condition. For the Kafka, that is for the Jakarta city. These are some of the models that have been generated, like which gives the average cloud cover, average humidity, and for the max join, maximum wind speed, maximum temperature, and the weather condition, it will take out what is the maximum bad weather condition, like thundery outbreaks in the nearby. So moving forward, this is the result for the DBT run for the different models created. Like you can see it is successful. So DBT snapshot and DBT test results. Snapshot and for the test, not null and other things. These are the results. So for the continuous integration part, we have used GitHub. We have not done continuous deployment because it has been done in Airflow through Docker. So in the continuous integration part, we have used this through GitHub Actions, but somehow we were not able to do it because of the syntax error, which we got through the SQL linting. So we are trying to fix on this continuous integration. So 3 steps are still pending in this. And lots of error need to be resolved for the syntax part through SQL flap and SQL test. So this is the snapshot of the continuous integration through GitHub Actions. So moving forward for the deployment or Airflow of our project, we have deployed it on Airflow through locally, because we have not used any platform like AWS because it was costly. So we have deployed it locally on our local host 8080. So we have made a folder called Airflow. Inside this was a DAC folder. Inside that we have created a DBT folder. And inside that DBT folder, there is Airbyte Snowflake, which is the actual DBT folder, which I've used for DBT run. And we have also done, you can see like weather underscore etl7.py. It contains the Airflow process for executing this DBT. Like you can see, like we have used a bash operator for executing our project, in which we have applied bash operator, tax ID, DBT build, and then we have given the path of this. And these are the CDT, temp, and DBT, Airbyte, Snowflake, and other credential that you can see below that are through the Docker. And we have used Docker through Docker to implement this. We have used extended Airflow in order to make it more comfortably execution of the Airflow. Normal Airflow will cause some of the problem in implementation of this files, DBT files. So we have used extended Airflow. The different commands for the execution of the Docker is given in the Docker file. So moving forward. So these are the results for the implementation of the Airflow through Docker in localhost 8080. We have deployed it locally. Since it is running, you can see whether ETL7 is running. And this is the running screenshot. And it is automatically auto-refresh. So moving to the visualization part, we have not done much in the visualization. We have made some of the visualization. We are working on that. So we have done connection with the Power BI to our Snowflake in order to abstract the different models that we have done through the transformation part. So you can see like minimum max for the each day, average mean. For the Jakarta city, we have only done. For the pressure, feels like humidity, cloud cover. And for the average mean max measures for the different parameters that we have used in the weather API generation. So moving forward, this is our GitHub repository in which we have pasted our whole codes and everything and the results. And we have used GitHub for our pull, push and everything. So thank you. So any questions you can ask?
Thanks, Puja. Awesome work. Round of applause. Yeah, feel free to folks to ask any questions you like to Puja or give suggestions or comments for improvement. Yeah, thanks, Alex. Yeah, Alex just commented saying he loves the use of Kafka.
Yeah.
Real-time processing happen.
Yeah, there's use of Kafka, but it was hard to flatten it because in real-time data sets, there are number of columns running per second. So
yeah, Chris. Thanks, Chris. All right. So no questions or feedback. We might move on to the last presenter, if that's all right. All righty. So thanks, Puja. Awesome work again.
okay, thank you.
All right. And now for the very last presenter of the demo day, before we jump into some time for networking, we have Dennis Chan up to present.
Right. Thanks, Jonathan. Give me a second. I gotta set this up.
Yep, no worries.
Right. So good morning, good evening, good afternoon, everyone. My name is Dennis, and for this capstone project, I'm actually doing more of a financial focus kind of project. The reason for this is because I used to work as an investment analyst at a hedge fund, so I have an inherent interest in that field. So just to give a little bit of background on my capstone project. So I made use of the Alpaca API, which is basically a finance API where you can get like historical data of stocks. It's also a live data set that refreshes every second. But the problem is that I'm quite a cheap guy, so I don't like to pay for services. So I can't access the latest 15 minutes of stock data. So that's the downside. So I prepared this data pipeline for a few people actually. So the first group of people are the normal users. So this group of people, they are basically only concerned with the daily movements of stock prices. And right, Jonathan as well. And the second group of people are the quants. So for those who are not too familiar with what quants are, they are basically traders that make use of algorithms to trade the market. And the most famous one is a hedge fund called Renaissance Technologies. And they are even more successful than Warren Buffett. So just putting it out there if you guys are interested. So these people, they are usually using these data sets for data science and finance related applications. So this is the data architecture that I've made. So on the left, obviously, is the Alpaca API. And I've done something that's pretty unconventional, which is I've put in a Python script that will ingest the data into the AWS RDS. And then I made use of Airbyte to transfer the data over to DBT and Snowflake. And lastly, for the data visualization part is done through Preset. So As for the data orchestration, I made use of Airflow and other alternatives, which I will go on to explain later in the presentation. So a quick question, a lot of people ask me like, why am I writing custom Python code for ETL process, since there are so many high level solutions that are available, right? So I had an intention to do quite a large number of customizations, which can't be done with Airbyte, so I have no choice. And another thing that I initially wanted to do is I wanted the user to have like a UI interface that can change the output and stuff. I mean the inputs and stuff, but I didn't have the time to complete that. So yeah, I ditched that idea, unfortunately. So let me go on to explain the data set. So as I've mentioned previously, is the Alpaca data set. And basically what I did is I did a full extract of 30 days worth of data on the first extraction. And following that, I did a 1 day worth of data extraction every single day. So I had to do some pretty crazy transformations because the data set is that I've chosen is pretty hard to work with. And as you can see, all of these are done using SQL. So yeah, I had to use a lot of ChatGPT, not gonna lie. So yeah, I also made use of DBT Cloud because I am quite a lazy person, so I don't really like to set things up on my computer, and I'm also using a 2019 Mac. So as you can imagine, the RAM isn't that great. So I made use of DBT Cloud, and I just wanted to go through this a little bit because from my knowledge, not a lot of people like to use DBT Cloud or have experiences with DBT Cloud. So the good thing is that it allows you to do pull requests directly. So that's got to do with CI/CD stuff. But debugging is quite a hassle because the UI is not intuitive at all. But it's on the bright side, it's pretty easy to set up and easy to deploy, and it allows for direct scheduling. I also did some DBT tests, but I didn't really go crazy with the tests. I did some testing on the date columns mostly because I use it as the primary key. So if the primary key breaks, yeah, the whole thing will probably fall apart. So I have to do some tests on that. I also did a bunch of DBT transformations. I will just go through the most difficult one, which is something known as beta. So beta is basically a finance concept. Think of it as volatility, right? Like how much the stock move. So you can imagine like a risky company would probably move more on a daily basis as compared to a company like I don't know, Coca-Cola. Think of Bitcoin versus Coca-Cola. That's the best way to imagine it. So I actually did this for a few companies, namely Apple, Microsoft, Tesla. And yeah, as you can imagine, Tesla has the highest beta. And thus, in financial terms at least, it's considered as the riskiest stock in this basket of stocks. And beta of 1 basically represents that it is the same level of risk as the general market. But if it's greater than 1, it means that the stock that we are looking at is more volatile and thus more risky than the broader market. And the reverse is true, where a beta of less than 1 means that, sorry? Oh yeah, sorry. A beta of less than 1 means that the stock is less risky or less volatile than the overall market. And the reference index that I've used is the SPY, which is the S&P 500 index. So as I've mentioned previously, I made use of Airflow for data orchestration. The pros is that it is relatively easy to use, and you can just use one tool for every single thing. But the cons is that it is extremely, you can see the diagram below is basically an overkill in my case, because there's only 4 decks. So yeah, there's not really a good reason to use it. And it's also very expensive. You need a T2 large in production. So it's not entirely practical in my case. So I came up with an alternative, which is to use a non-Airflow method. And the pros is that there is no additional cost. And the cons is that I have to set things up individually. So as you can see on the bottom, I made use of cron job on render.com, which is similar to AWS, to run my Python script. And then Airbyte, actually there is something called Airbyte Cloud as well, which you can use to schedule, and it's on the cloud, so you don't have to sell anything. And also I made use of DBT Cloud, which also have a built-in scheduler. And lastly, actually this is not really necessary because Preset I mean, if you click onto preset, it will just refresh by itself. So you don't really have to do much. Okay, so this is the cron jobs that I ran. So I ran it from 8 p.m. to Monday to Friday, basically. And the rest are all pretty much the same. So as for the dimensional models, I did it for two different, like I've mentioned earlier, I do it for two different groups. The first group is normal users. So these are users who basically only want to know about the date and stock movements for that day. So yeah, these are my dimensional models. And this is the one big table that I combine everything in the end in order to use preset and for easy like visualization. The second group is for quants. So I added like a little bit of extra stuff like beta, and I also calculated the daily returns in percentage terms so that it's easier for these users to do some more advanced analysis. And yeah, this is the final visualization. I didn't really go crazy on preset because I'm still trying to figure out how to use it. It's easier to, in my opinion, it's easier to write code than to use preset. But yeah, I don't know. That's just my opinion though. So yeah, I've come, oh, sorry, there's one last one. So for the lesson learned, okay, initially I choose this data set because I'm really interested in finance, but I realized that it's quite a difficult data set to work with because I need to do a lot of transformations. As you can imagine, like even though I managed to get like quite a number of tables from the REST API, their dimensions are more or less the same. The columns are more or less the same. So there isn't too much that I can work with unless I do a lot of transformation on my end. And the next lesson learned is that dbt Cloud is such a headache to work with because there's no tutorials on dbt Cloud about their user interface. And I was basically stuck there for weeks until Hengji and Jonathan helped me figure out like how to use it. But yeah, but beyond that, it's actually pretty good. It's ideal for people who don't want to really sell anything on your computer. And yeah, the last lesson learned is that you have to try to set up your Snowflake RBAC correctly the first time, because I had some problems setting up the first time, and following that, everything else was pretty much a mess, and I have to set it up again. Yeah. So yeah, just to give you guys one example of the issue with dbt Cloud's UI is that, okay, on the bottom is the CLI, but they never tell you where the CLI is. So you never know until like I start clicking around. Like on the last few days, I finally figured out where it is. So yeah, that's good, I guess. So yeah, that's the end of my presentation. Let me know if you guys have any questions.
Oh, awesome. Good work, Dennis. Round of applause. Good job. I can see a question in the chat from Alex. Alex, if you want to ask a question again.
Yeah, sure. Yeah, just on the writing bespoke code, because you were having sort of troubles with Airbyte. Airbyte's got the ability to write custom connectors for it that gives you like a it's got like a development kit that you can use to write your own custom connectors. Did you give that a shot at all, or you just
okay, so currently I'm working as a software engineer for a construction company. So I'm pretty aware of like how the most difficult part in programming is not actually writing the code, it's the integration part. So I didn't really want to spend too much time writing custom connectors. So yeah, I have to go with the ETL instead. ETL Python script. That's much cleaner and easier, I think. At least for me. But yeah.
Yeah, I mean, if you continue build, because you know a lot of people from the bootcamp like continue working on their projects even past it. It might, like, even for a learning thing, it might be worth having
definitely. I'll give that a shot.
Yeah. We got it to do some stuff with some really weird government APIs. So you can do some cool stuff with it, and that'll just let you.
Does it work for the weird APIs that you're mentioning?
Yeah.
Oh,
yeah. It's worth a look. And John, you can probably correct me on this, but Fivetrain lets you write custom connector sort of stuff as well, right?
Oh yeah, but unfortunately, actually I did read about that, but Unfortunately, we didn't learn Fivetran within this course.
Oh yeah. I just mean like from a point of like, it's a common thing to have your integration tools have like a CDK that you can use. So you'll see it everywhere.
Yeah, thanks for the suggestion. Really appreciate it. I'll try it out next time.
It's good work. It's good work. It's good work. It's just, yeah, there's features out there that you can look at.
Yeah, no worries. Maybe Jonathan can have a more advanced data engineering bootcamp where you go through absolutely everything in the universe about data engineering.
The data engineering universe course.
Yes, and you get a degree at the end or master's.
Oh, nice. Any other questions from anyone in the chat group? Feel free to unmute yourself and ask a question or give your suggestions as well.
Well, if you guys are interested in finance stuff, I can also explain.
Is there any improvements in your project you think in the future?
Sorry?
Is there any improvements that you can do in your project in the future?
Oh, future improvements. I mean the most obvious one would be the preset, because I had quite a tough time figuring out how to use it. That's why I only came up with one. But yeah, in the future I'll definitely work on that. Apart from that, I guess there are a lot more things that you can add in. But in my case, right, for quants especially, it's not entirely efficient to run all of this code using SQL, because a lot of these transformations are pretty complicated. So you probably have to use Python instead. So actually, in my particular case, Databricks might be a better solution, yeah, rather than using like DBT and Snowflake and stuff. So yeah, I see that you have a question, right, Jonathan, about quants?
Oh, no, not a question. More of a
Oh,
comment.
okay.
Yeah,
No
it's
worries.
just good analysis. Yeah.
Right. I guess that's all then.
Cool. All right. There are no other questions. Thank you so much, Dennis.
All right, no worries.
Well done. So we'll jump into some networking time now. Just share my screen here. So again, awesome work to the presenters. Kudos to you guys for working in your projects and showcasing it to the wider data engineering community. Yeah, as I said, we'll jump into networking now. So I hand it over to Douglas. Douglas, if you want to introduce us to the activity that we're going to be doing.
Yeah, cool. Thanks for the presentations, Puja, AJ, and Dennis. We're going to jump into a few rounds of speed networking. Now, some people might not have done this before, but it's going to be quick. So it's going to be 3 randomly allocated 5-minute rounds. And then each round will have a question that's advertised or broadcasted for a discussion point, but it's genuinely quite free to talk about whether it's projects, the industries, whatever comes up. Again, the benefit of this is to pool industry knowledge, any opportunities for collaborations or partnerships potentially, and even career advancements down the lines as well. So the first question is going to be broadcasted, but to start you off, it's going to be, what do you think are the most popular or your own favorite data engineering tools and why? Now, some people might not have used many data engineering tools. Some people might be managers of data practices. If you haven't used any, it can be a case of what do you know about the industry and what have you seen before? Or if you're well advanced, then you can lead the conversation.
All right, I'll open up the rooms and we'll give us 5 minutes to discuss that topic. Oh, there we go.